Hello everyone, my name is Rajat, a former Microsoft engineer and an educator and founder at Bosscoder Academy. Welcome to this class. In this class, we are going to learn about the scalability aspect of streaming platforms like Netflix. I hope you love the class. Whenever you are given a system design problem, either in the company or either in an interview, the first step you should do is, while you are solving a system design problem, is to come up with something known as a MVP, which is known as a minimum viable product. Or you can, some people say this, that you have to scope down the problem or really understand what is the problem state, right? So let me give you an example. So tell me, what are the different features that you see within Netflix? For example, one feature that I see within Netflix is I can stream movies or series. Can you tell me what more features, what more you can do from Netflix? Watch list, definitely. You can have a watch list. You can have payments, definitely. You can download. I'm not sure if you can download, but yeah, you can download, I think, locally. You can do search as well. Can we play games? I'm not really sure. There is definitely a recommendation system, which is personalization. There is subscription. With subscription, there is also user profile. There are trending videos, definitely top trending series. Favorite is, I will just like right here. Recommendations, I will write ratings here. Short videos, are there short videos? Not really sure, but let me just write it down. Short videos. 5 people can watch at the same time. So 5 people watch same time. Upcoming movies, okay, that's not really a feature. There is definitely a feed that is there. That is on search, that you can search by name, you can search by genre or whatever it is called. You can search by different things. Okay, there is definitely login and sign up. Let me just, feed is just list of movies. Okay, let me just have it. There are login, sign up, all those things. Okay, let's just keep up till here. So what I just wanted to say is are a lot of features within Netflix. It's not just one thing. Also, you can all of these are on the user side. There is also backing side, right, where you can upload videos, like upload videos /series /movies, right? All those things are also there. So if you see, no Adish, so this class is meant to be attended live. I will definitely share the notes of this session, but itself will be live only, right? So what I wanted to say is there are a lot of features within Netflix, and you cannot design all of them in the first version of the product. Think of the first version of Netflix. Does it have all the features? Or think of when you first use Facebook. Is it the same that it is right now? Or Instagram, is it the same when you used it the first time? No, right? So how does product development work is that you start with some bunch of features which are core to your product, then you test it with the users and then add more features. So this is something known as a minimum viable product, that you start with the MVP, right? Or if you are in an interview, you cannot design all of it in a 1-hour interview, so you scope down the problem. Or if you are in an actual company, you actually go about understanding what am I really building when someone says Netflix. So let's define what we are building today in our lecture, right? So we are definitely building streaming of videos at scale. So a lot of users watch Netflix around the world. So we will definitely discuss it. We will not discuss watch list or favorites. We will again not discuss payments as well. Payment is again very separate design itself, right? Which itself requires one lecture in itself, right? What is this? What I have written is not sure. Okay, just leave it. I'm not sure what I have written. Download. Okay, down. Sure. So, download. Okay. So download. Let's not discuss download. Search again. We are not discussing recommendation system. We will talk about in some sense how does the recommendation system actually get powered here, and we will talk about ratings. We will talk about subscriptions. We will talk about user profiles. We will not talk about top trending. We will again not design short videos, which again itself is a whole design like TikTok or Instagram Reels. Whole design. We will not talk about 5 people watching. We will just talk about 1 people is watching 1 video at a time. Right? Feed we can talk about. We can definitely talk about feed. Login sign up is pretty basic, right? There is nothing too much to talk about it, so I will not talk about it. It's very basic. And upload videos, since this is not at scale in terms of Netflix, right? So uploading videos, if it is YouTube, then definitely upload videos is at scale. But if you are talking about Netflix, then upload video is not at scale, right? So we will not discuss this as well. So does this make sense? So what we are discussing today, when I say as Netflix is a video streaming platform, right, where someone can create their profile, right, which is create profile. There is a user profile. Someone can subscribe, can buy subscriptions. They can stream videos, right? And there is a recommendation engine and a feed and recommendation engine. Does this make sense? The major piece we will talk about is this streaming of videos at scale. How do we go about streaming videos at scale? Does this make sense? Does this step 1 make sense? Why we are doing it is to understand what we are actually building. Someone might say you to build like a watch party, right? You know, there is a watch party where multiple people can watch Netflix together. Right? Now that's a completely separate design than streaming videos at scale. Or payment is a completely separate design from streaming videos at scale. So it is really important as the first step, whenever someone throws you a problem statement, like let's say design Facebook, design Instagram, design Paytm, really understand what you are designing. Okay, you can ask questions related to that. Once you are done with this, yeah, we are not discussing content protection. There might be like country specific laws as well. All of those we will not discuss today. This was the first part. Now, once you are clear with what you are designing, let's discuss like what is the scale you are designing. So whenever you are designing something like a video streaming platform or a streaming platform, like Netflix is a streaming platform, or you can think of Hotstar or Geo Cinema, which also host these live events like IPL or World Cup. These are also one type of systems. How do you go about doing Hotstar or live systems? There are also these systems like Zoom, MS Teams, right? Or Slack, which basically does these live interaction, or I would say peer-to-peer interactions, right? So this is also a separate kind of design. There is also one type of design like YouTube, where anyone can upload. I can also upload videos. So there is upload, there is scale, and then there is streaming. Also, there is scale, right? So there are these different type of things. Whenever you are designing a streaming kind of platform, there are 2 things that you should talk about in scale estimation. One of them is your storage requirement, and the second part is your bandwidth, right? Does this make sense? So whenever you are designing a streaming platform or anything like this, think of these 2 things, storage and bandwidth. What do they actually mean? Let's talk about them in some detail, right? Everyone clear till now? A quick yes, and then let's move to storage estimation. A quick yes just gives me the motivation that yes, everyone. QPS we will not define too much here, like bandwidth will take care of that. And that is why we are skipping QPS. But yeah, if you're designing something like Facebook newsfeed or something like that, you definitely think of QPS. Okay, so let's talk about storage, right? So tell me, what kind of data are you storing when you are designing this? So think of MVP, right? Like again, or always think of what you have decided you are building. So one storage that you are definitely storing is like movies itself, right? Right? Movies or these media data you are itself storing. Second is you are storing these user info, right? Like user related data, which is going to power the recommendation system. In order to suggest you any movie that you are likely to watch, I need to store all the movies or all the interactions with different movies you have, right? For example, you opened the movie and you watched it completely. That's one indication that you like this type of movie. Another is you opened the movie but left it midway. That's another interaction that, okay, this is not something that you really like. So you have to store all of that. Another thing that you have to store is, yeah, we will talk about SQL, no SQL. Yeah, we will talk about it. The second, one more thing you have to store is really the movies data. What is movie data? Movie data is like movie name or subtitles, right? Or cast details, who is the actor, who is the heroine, everything, all of those things. What is the description? All of these details also you will store in the storage. So I think these are the three things that you are storing actually when you are talking about in respect to your MVP. So let's talk about each one of them in how will they, like, what is the estimation. So let's talk about the movie data or the media data itself. So tell me, what do you think, how many number of movies are there on Netflix? Is it like can you tell me, is it like YouTube? Like YouTube can have infinite number of videos, right? Anyone can upload. But for Netflix, it is not the same, right? A quick yes, if this makes sense. Like there is a difference between Netflix and YouTube in terms of video data. Right? Yeah. So Netflix, yeah. How many movies? Some are saying 15K, 4K. The last time I checked, there were 15,000 movies according to Google. That there are around 15,000 movies on Netflix. Okay. Now, what do you think? Are movies stored in just one format or movies are stored in different format? Movies will be getting stored in different format, right? Again, live events we are not building. If there is a live event in the MVP, we are not building it. There might be live event on Netflix, but we are not building it right now. So format of movie can be, there can be 240p, 480p, 720p, 1080p, or 4K. Multiple dimensions can be there. But let's not go into so much detail, and let's just talk about that there are just two dimensions, SD and HD. SD is standard dimension, HD is high dimension, right? Let's just talk about these two dimensions, right? Okay, so let's say SD is streaming as 10 GB per hour and HD is streaming as 20 GB per hour, which means for 1 GB of SD movie, it is taking around 10 GB to store. Sorry, 1 hour of SD movie. And for 1 hour of HD movie, it is taking around 20 GB to store. Okay. Make sense? Right? So this is another thing we have established. What do you think? What will be the average size of the movie? Like average duration rather than size, let me say duration. Will it be 1 hour, 2 hours, 1.5 hours? Some series might be smaller of 30 minutes, 45 minutes. Some might be very big. Movies itself, I think it will be around 1.5 or something, but let's, for ease of our calculation, let me take as 1 hour, right? You can take it 1.5 as well, just ease of calculation, I am taking it 1 hour. right? Again, it's an average, depends on creation definitely, but on an average, what do you think? Again, these are estimations. We are not really talking about actual, just doing estimation. So what will be the total size now? Can you tell me? Total size or total storage required. So you have 15,000 movies, right? Each movie on an average is of 1 hour. Okay, and each movie you are storing in 2 dimensions, HD and SD. So for HD, it is taking 20 GB per hour. And for SD, it is taking 10 GB per hour. Does this make sense? So what will be the total storage? This will be the total storage. So this will be around 15,000 movies into 30 much storage, which will be 45 into 10 raised to the power 4 GB, which is 450 terabyte. Does this make sense? The storage required to store movies. Everyone clear with this? A quick yes. Okay, so this is first part. Okay, makes sense, makes sense. Not very, very huge, right? Definitely huge, but not very huge. If you would have done the estimation for YouTube, you would be surprised that there are petabytes of storage that is required. We did a masterclass on YouTube some weeks back, and it was petabyte. So definitely, right, like the system design changed in both the perspective. Okay, but yeah, I think makes sense. The next part is, let's talk about the movie data. What is movie data? Movie data is something like movie name or cast details or description, director, subtitles, movie ID, definitely. Yeah, type of it. What is the type of movie? What is the genre? What is the country? Multiple things will be there, right? So what do you think? How much will one movie will be taking? Like storage required to store this detail for one movie. There would definitely be movie link. 1 MB, I think, is too much. It's just data, right? Like just data, nothing else. Too much, right? So I think around few KB we can say, right? We can say subtitles will be big. So subtitles will be around 50 to 100 KB. So we can say around 100 KB or 200 KB, right? Whatever you think of. I am just taking 100 KB. You can take 200 KB as well. Okay. So how much total storage is required? There are 15,000 movies, and for each movie they are storing around 100 KB, which will be 1500 into 10 raised to the power 3 KB. What is 1000 KB? 1000 KB is MB. So it will be 1.5 GB of data. Is it very huge? This is very less, right? Like very, very less. 1.5 GB is nothing. So this is very less. So we don't have to think really about scale here. We definitely have to store this, but not really think about scale, right? Yeah, which type of DB we'll use, just we'll talk about in some time, in 2-3 minutes. And then let's talk about the user details as well. So what do you think? How many total number of users are there on Netflix? Like how many total users will be there on Netflix? $4 million. Okay. PowerPoint has 200 million monthly active users. So I think it's similarly like Facebook has in billions, Facebook, Insta, but Netflix also have similar kind of people. So on an estimation, they have 200 million users, right? Again, these are estimations. These are not correct data. If you are in an interview, you should confirm it with the interviewer. So you can say to the interviewer, I think Netflix might have 200 million active users. Is it the right estimation? And the interviewer might say, you know, let's take it 500, let's take it 100. Or if you are in an actual company, you will know this estimation. Basically, from the past data, right? Make sense? And it might change. So let's take it 500, right? Let's take 500 million. Okay. Okay. Again, it's an estimation. Let's take 500 million and talk about based on that. Okay. You will have this idea when you are in actual company. Okay. Okay. Makes sense. If there are 500 million users, what do you think? What is the lifetime? What I'm trying to calculate is, what will be the user data if you think of? User data will consist of two things. One is the user profile data. What is user profile data? User profile data is name, gender, right? Subscription detail, right? Photo, user ID, username, password, multiple things, right? And the second thing will be in user data itself. One will be the user profile data, and the second is user interaction with movie. Is it making sense? For example, Rajat might interact with multiple users, right? You joined just now. So if you joined just now, Sanskriti, we are designing Netflix. In Netflix, we are talking about how much. Yeah, you have missed something, but I think that is fine. You can start from here as well. So if I give you a 2-minute recap, we are working on designing Netflix. Within Netflix, we are right now talking about how do you go about estimating the how much storage will it require to store the users details, right? In users, we are saying there are 500 million users on an estimation. User data will consist of two things: user profile data, which is something like this, and there will be user interaction with movie. For example, Rajat might interact with multiple movies. For example, Rajat might interact with Bahubali, might interact with Batman. So might also, so I am not watching too many movies nowadays, but yeah, I think some more movies, whichever is coming by, I think those are also, Rajat can interact with all those movies, right? And yeah, Adi Purush as well, definitely. And similarly, Deepak might interact with multiple movies, right? And when they are interacting with movies, right, there are different outcomes for every people. For example, Deepak is watching Bahubali and Adi Purush, and Deepak might not like Bahubali and like Adi Purush a lot. Right? This can happen. Right? Deepak finds it Adi Purush to be great, but not Bahubali. Whereas Rajat finds Bahubali to be great. This can happen. And then hence, both of these interactions are different and you have to store them separately, right? Does this make sense? A quick yes, and then let's talk about calculating user data. Right? So let's talk about user profile data. I think user profile data is pretty simple. Yeah, I can repeat once. So what is the user data consist of? User data consists of two things. One is what is the user profile data? For example, what is my name? What is my gender? What is my subscription details? What is my photo? That is the first thing that I am storing for a user. The second thing that I am storing for a user is the user interaction with the movie. For example, if I watched Bahubali, I might like it and completely watched it. For example, for Deepak might have left Bahubali in between of 5 minutes. So there is a point that Deepak does not like Bahubali a lot, and it left it in between. That is going to feed the recommendation system on what next movie to suggest to Deepak, right? Does it make sense? Right? So let's talk about the user profile data first, maybe. So user profile data is mostly simple. So what do you think, how much for a single user, right? Average storage for one user required. Like we are storing multiple things like name, gender. How can you estimate it? You can estimate based on characters. You can say name is 20 characters, gender is 5 characters, subscription details is another 5 characters, photo is this much. And then you can say one character equals to 1 byte. And then estimate. Okay. So let's say 100 KB or let's say 50, like I don't think there will be 100 KB because in earlier cases it was 100 KB because there were subtitles and they were pretty big. So we can say mostly it will take 5 KB or 10 KB to store all this data. Right? So let's take 5 or let's take 10 KB, right? And there are 500 million users. And let's take there are 10 KB. 10 KB. So it will take 5,000 KB into million. What is a million? Million is 10 raised to the power 6. So can I write it like 5,000 KB into 10 raised to the power 3 into 10 raised to the power 3? What is a 1000 KB? MB, what is a 1000 MB? Or let me just like left it here itself right now for now. And we will do this later on, right? So let me like ease out the calculation, otherwise it will become hard. So for user profile data for single user, I would say the average will be, let's say 1 KB. And I will tell you why I am doing so, but let's say for a single user, it is 1 KB as of now for one user. Now let's second calculate is the user interaction with movie data. So number of users, we know that there are 500 million users. Now tell me how many movies on an average a user will watch in his or her lifetime. We have to calculate it, how many movies a user will be watching in his or her lifetime on an average. To do so, we can start with what will be the lifetime customer value. What will be the lifetime customer value according to you for Netflix? What do you think? Can I say 10 years? That people usually stay on Netflix for 10 years, right? It can be higher as well. It can be 20 years as well. Or it can be 10 years, right? On an average, let's say 10 years, people are watching. Some people might just watch for 1 year and then left off. Some people might watch it for 10 years, 20 years, 30 years. So on an average, we can say 10 years is the lifetime value. What do you think? How many movies people will be watching in a month on an average? Weekly 2, so we can say maybe 10 movies in a month people are watching on Netflix. Those who have subscription, they are watching, let's say 10 movies in a month. So how many total number of movies are people watching? So they are watching 10 movies a month, which means in a year they are watching 12 movies, right? And we are saying that the lifetime customer value is 10 years, right? So we can say 1200 movies, right? Did I miss something? Yeah, 1200 movies, right? In lifetime on an average. Okay. So now this is how many movies people are watching. Then for single user, Rajat, if Rajat is watching 1200 movies in his lifetime, there will definitely be interaction with all those movies, right? So what do you think, what one interaction will look like? Rajat movie, any one movie, how much this one interaction will look like, right? What are details will be there? So details can be how much watch does Rajat have on this movie? Did Rajat press the like button here or not, right? Uh, did the user binge watch it or paused it multiple times, right? Yeah, movie ID, time left, on what time it watched the movie, right? It can help understand at what time people are watching movies, right? Like what is the preferable time for them. All these can be watched, like can be calculating. Let's say for one user, it is 1 KB. All of this is taking 1 KB of time of watching movie, right? So then for single user, what is the, how much are you storing in terms of movie interaction, user interaction with movie? You are watching 1200 movies in lifetime, and you are storing 1 KB for each interaction, each user movie interaction, right? Is this making sense? Everyone clear with this, or is it like I can go through it again in the end, like after this, if you are not clear, right? So what is the total storage in terms of user details? It will be number of users into storage for each user. How many total number of users are there? 500 million. What is the storage for each user? Storage for each user is one, user details, and second is user interaction with movie, right? So it will come out to be 500 million users are there, and for user details it was 1 KB on an average for single user, plus it is around 1200. This is 1.2 MB, right? 1200 KB is 1.2 MB. So I can neglect this part since this is very, very small, right? So I can write it like 500 million into 1.2 MB, which will come out to be 500, 1.26, it will become 6, right? So it will become 600, right? It will become 660. Yeah, it will become 600 million MB, which will become 600 MB into 10 raised to power 6. So it becomes 600 MB into, what is a 1000 MB GB? What is a 1000 GB? Terabyte. 600 terabyte of storage. Is this making sense? Do anyone have any doubt in user detail? And I can go through it once again if you have any doubt. Or is it clear? How many it is clear? Like a quick yes if this is clear. How did we calculate each like user details? Yeah, I will revise. Yeah, definitely. Okay. Okay. Okay, I can unmute one person and I think that will be easier. So anyone who wants to volunteer for like going through it together, any one person, and I will unmute them. Saurav, should I unmute you? Maybe I can schedule some bit. Okay, Saurav, I have unmuted you. If you can like speak and we can go through it together. No. Are you able to hear me, Saurabh?
Yes, sir.
Okay, Saurabh. So let's go through it together, right? So is this part clear, Saurabh, that users detail will consist of two factors, right? What are those two factors? Can you tell me?
User. It can be name, user ID, email,
Yes.
subscription details, and payment details.
Yes. And all of this will consist of the user profile data, right? Right. All of these
Yeah.
are user profile data. Make sense? And the second part also will be the user interaction with movie, right? For example, let's say Saurav, you watched Bahubali. So you have an interaction with Bahubali, right? You might have liked it. You might have done something else, right? So please keep yourself right unmuted, because like then you will not get muted yourself. Like, so that is also there, right? User interaction with movie. So any user data consists of two parts: user profile data and user interaction. Is this clear?
Yes, sir.
Okay. Now we said that total number of users will be 500 million on an estimate. This is also clear.
Yes, sir.
So first thing we are doing is we are calculating the user profile data, right? So what we said is to store all of this user profile data, it will take 1 KB for one user. Is it fine? 1 KB per user.
Yes, sir.
Right. And then we've started finding user interaction. So to find user interaction, we have to find how many movies on an average a user would have watched in his or her lifetime, right? Make sense?
Yes, sir.
If you have any doubt, feel free to ask, right? So to calculate how many movies a user might have watched, we will start with what is the customer value, lifetime customer value. So we said any user on an average will stay for 10 years on the platform. Like they will have the subscription for 10 years on an average, right? So yeah.
But how can we show that it's 10 years? Because like even after 2 years, people leave according to the data.
Yeah. So we are not sure. We are estimating, right? Some user might leave it in 1 month itself. Some people might stay it for 50 years, right?
Good. Yeah.
Right. So on an estimation, we are saying that let's say on an estimate, people stay for 10 years. Right. Our estimate might be wrong, but we are doing scale estimation. Okay. Make sense?
Yes, sir.
Okay. And then we are saying how many movies are people watching in a month on an estimate, on an average. Some people, for example, I have a Netflix subscription, but I have not watched it. I don't even remember when is the last time I watched a movie. Some people might watch like a lot of movies as well on Netflix, right? So we said on an average, people might be watching 10 movies a month, right? Okay. So how many total number of movies people are watching? One user, how many total number of movies one user is watching? So that is any user is watching 10 movies a month, and they are watching the movie for 10 years. So if they are watching 10 movies a month, then it will be 120 movies a year, which will be 1200 movies in lifetime, considering they have the subscription for 10 years. Is this clear?
Yes, sir.
Right. What is not clear, Saksham, in this? Like any user is watching 10 movies on an average in a month. And so how many movies are they going to watch in 1 year? 12 into 10, because a year has 12 months, which will be 120 movies in a year. And now we are considering that this user will stay on the platform for 10 years. So they will be watching 120 a year. So how many they will be watching in 10 years? 1200 movies in lifetime. Yeah, Saksham. So now every user is watching 1200 movies in his or her lifetime. So with every movie, you are storing some interaction. For example, Saurav, you might have watched Bahubali. And similarly, on an average, you have watched 1200 movies more. For every movie, you might have some interaction. For example, how much time did you watch this movie? Did you like this movie? Did you binge watch it? At what time did you watch this movie? What was the subtitles you were using when you were watching movies? What is the audio you were using, right? Like all of these things have to be there, which Netflix would store to power its recommendation system, right? Make sense?
Yes, sir.
Right. So we are saying all of this is taking 1 KB of information, 1 KB of storage. So then we are saying that for each user, the movie interaction is taking 1.2 MB, because there are 1200 movies a user is watching in the lifetime, and for each user there is 1 KB of interaction, which means 1.2 MB, which means the total storage per user will be number of users into storage for each users, right? Which will be 500 MB plus user details plus user movie interaction.
So can you just repeat from from 1200 in 1 KB, yeah, from there.
This is clear?
No, sir. Yeah, from there only, sir. Just
this is clear, or this is also have a doubt?
Doubt. That is the doubt. That's the main doubt. Actually.
So there are 1200 movies a user is watching in lifetime, right?
Yes, sir.
And for each movie, you're storing the interaction in 1 KB of information, right?
Yes, sir.
Right. So Saurabh Bahubali will take 1 KB of data of storage, and there are 1200 movies that are total. So what will be the total storage for Saurabh required to store Saurabh interaction with movie is 1200 into 1 KB, which is 1.2 MB. Right?
Yes, sir.
So what will be the total storage now? Just multiply it with total number of users. How many users are there? 500 million users. So we multiplied 1.2 MB by 500 million, and it comes out to be 600 terabyte of storage. Okay.
Yes, sir.
I think makes sense. I think it would be clear to almost all of you. If there is still doubt, feel free to ask in the comment and others can help out, or you can ask in the end. I will share the notes. You can go through them at that time as well. Right. So if I conclude the storage wala part, then we have 3 types of storage. We stored movie media, which for us took how much storage? Which for us took 450 terabyte of storage. We also stored movie details, and we also stored user details. User details took 600 terabyte of storage, and movie details took 1.5 GB. Is this clear? A quick yes if this is clear to everyone, and then let's move forward. Right, again, if anything is not clear, I will share the notes and you can go through them again, and it will get very clear, right? Okay, makes sense. Chalo, great. Let's move forward, right? I will cover bandwidth, but I will cover bandwidth later on. Let's now move forward, and I will cover it like later on. In this lecture, I will cover it, but let me just cover it in a later stage, and let us pick up some speed to move to the design, and then in design we will pick up bandwidth. Okay. Yeah, Saurav, you can write it in the chat window, and I will pick that up. Okay, so let's move to the step 3 now, and then we will again come to it. But let's talk about the design goals. In design goals, let's talk about the latency. What do you think in terms of latency? Do you want your movies to be loaded fast, or do you want them to be loaded slow? So do you want high latency, low latency? Right. You want your movies to be loaded fast. So you want low latency. What is latency? Can someone like do share it out in the chat window? But basically latency is if you are the user here and you are watching a movie, say Bahubali, and you press here on the button, then it will go to the server. This is the Netflix server. And this is your local computer, laptop, and it will fetch the movie and will get back here. So how much time, let's say you press the button at T1 and your movie starts at T2. Like T1 is when button is pressed and T2 is movie starts. So how much time does it take? Is the latency. Make sense? So latency is how much delay from the actual end-to-end everything. So you definitely want your movies to be loaded fast. So you want low latency, right? Give me some examples of high latency. Where high latency is fine. Live stream, no. Live stream, you want low latency. You want it very fast. Emails, right? Emails is one example where high latency is fine, right? IPL match, you want low latency. Uploading is also something. Uploading plus processing is something where high latency is fine. Notification is also one area where it is fine to have high latency, right? Let's move to CAP theorem. I will not discuss CAP theorem here. If you don't know CAP theorem, go to YouTube and you will find a lot of material. Very basic of system design, you will find it very easy. What do you think? What do you want out of consistency versus availability here? You definitely want partition tolerance, right? Like, because every system wants partition tolerance. If it's every distributed system has to be partition tolerant. So out of consistency and availability, what do you want? Like, availability means that when you're watching movie, you're able to watch movie if any server is available, right? So you want availability in this case. Consistency is fine. You can have eventual consistency. It is fine if some of you are not able to understand this. Go watch a video on CAP theorem and you will get it very clearly, right? Like after this class, you can go and watch a video on CAP theorem and you will get it very easily. It's a very easy concept. You will find it very easy to understand, right? So in CAP theorem, we want eventual consistency. We want availability. And we want partition tolerance, right? Okay. Make sense? Right? Yeah, just type CAP theorem and you will find it. Okay, make sense? With that, let's move to the design. Let's start talking about our design. Right? So now what we know is like very, very important. What we have known till now is very, very important. So we come to this lecture, like before you were in this lecture, you come to this lecture for designing Netflix, which is a very broad statement. No one can go about designing Netflix, partition tolerance. However, now you have much better clarity. You exactly know what you are designing. So you know the MVP of what you are designing. You also know what is the scale you are designing, right? So you know that for storing movies, I don't have to care much. But for storing user data and movie details, I have to think about it, right? Bandwidth is also a problem. We have not discussed it, but it's also a problem that we will discuss in some time, right? We also discussed what is the design goals we have. For example, whatever is our design should be able to deliver low latency, should be available, should have high availability, and should be eventually consistent. Considering these aspects, let's go about designing a system. right? Okay, let's go about designing a system. Okay. So first of all, let's start with storage. So if you remember, we have three types of storage, right? We have media storage, we have movie data, and we have user data. Tell me in what type of storage you will store movie data. In SQL kind of database, right? Where you can query something very quickly, right? Where I would say query is fast. Make sense? What is a query? Query is something like give me cast details of film Bahubali, and it can tell you who are all in the movie. So you want to store movie data in a SQL database, and this storage is since just 1.2 GB. You can store it in one SQL database. No need to think about scaling or all those aspects. When it comes to user details, right? Then where will you store user details? You can store it in NoSQL as well. You can store it in SQL as well. So let me just talk about which one will look good if you are actually designing it, right? So can someone tell me, like, why do you choose NoSQL or why do you choose SQL? So choose SQL if the schema is clear to you. If you know what is the schema you are going to use, and the schema will not going to change very frequently. Choose NoSQL if you are just starting up and you're not sure what will be the schema. Because if you are changing the schema in SQL, you have to take all your data that was earlier in the old schema and transfer it to the new schema. And that is going to result in a downtime, right? So it is very, very important that whenever you are talking about SQL versus NoSQL, think of what is the schema in your mind. Is the schema going to change very frequently? No, then choose SQL. Otherwise, choose NoSQL. That is why if you see nowadays, a lot of companies use NoSQL. Like at Bosscoder also, we use NoSQL. Why? Because we don't know, we might need to change our schema later on as well, right? And that is why we use NoSQL. And most of the startups use NoSQL, but very big companies, if you go to Microsoft, if you go to Google, they use SQL because they start, when they start off, they know what is the schema they are going to use. Right? Okay. If this is clear, now at user data, you have 600 terabyte of data. Tell me, can you store all this data into a single server? No, right? You cannot store this into a single machine. So you have to shard the data. What is sharding? Sharding is you have 600 terabyte of data. So you cannot store it into a single database. So what you do is take multiple database of, let's say, 100, let's say of each database, let's say, can store 10 terabyte of data. So how many you will need? You will need 60 such databases. And you will store this data. That means divide this data into these 60 databases. Does this make sense? This is known as data sharding. A quick yes if this is clear. What is data sharding? Clear? Okay. If this is clear, okay, so okay. So data sharding is, if you have, please be more attentive in this time, right? Because we will discuss some key aspects now. So let's say you have 600 terabyte of data. How are you going to divide the data into multiple database is what is known as data sharding. You cannot store 600 terabyte into one database, but you can store it in single 60 databases. Some data everywhere, right? For example, let's say you have a bucket of water, right? And you have these glasses with you. You cannot store all the bucket of water into one glass, but you can have a lot of glasses and store some water in all those different glasses. That is known as water sharding. What is so hard in this? Let's say you have this bucket of water and you have these small glasses. Can you store all this water into this small glass? No. Right? Right, Amit? You cannot store all in the same glass, but you don't want to lose the water. Every har ek boond of water is important for you. Every drop of water is important. So what will you do? You will store some water in this, some in this, some in this, some in this, some in this. Right? You will take a lot of glasses. This is known as water sharding. Similarly, you have a lot of data. You cannot store it into one database. So what are you doing? You are taking multiple databases and storing data in all of them. Some data in all of them. We will talk about, will get increased latency or not. We will talk about it. Just give me some time. Right? This is clear. Now tell me, how will you shard data? Like on what basis you will shard data? Okay, someone is saying I will shard based on user ID. Okay, someone is saying based on location. Someone is saying yeah, region location is same. Someone is saying I can store based on movie. Okay, I will just take these. You can be generic, can be time based. Yes, you can do generic, time based. I will not take all of them since I don't have a lot of time, but I will take like these three and discuss the advantage, disadvantage of them. More you can then do it by yourself after this class. So let's shard based on location. What does based on location means? That I have 600 terabyte of data. Let me have multiple databases. One database in North India that is going to store the North India data. Another one to be South India data. Another one to be West India. And another one can be East India. Make sense? And then what I am doing is I am dividing this data based on region. Is this making sense? A quick yes. Some data is stored in North India, some in South, some in West, some in East. A quick yes if this is clear. What is sharding based on location? Okay. Do you see any disadvantage in this approach? Yes. So Sen is right. Location might change. For example, Rajat might be in Delhi right now, but then can move to Hyderabad. Right? In that case, you have to transfer all the data from North to the South region. And since a lot of users are traveling here and there, you have to data transfer will be very high. That is why this kind of sharding is not a good way of sharding the data. Make sense? Does this make sense? A quick yes. Why sharding based on location is not a good idea and we should not do it. Okay. Let's take the second approach of sharding. Shard based on movie. So Bahubali movie will be watched by a lot of users, right? Rajat might also have watched it. Randeep might also have watched it. Abhay might also have watched it. Like multiple users might have watched the Bahubali movie. Does this make sense? A quick yes. Right? So now what can you do is you can store based on movie, right? So you have this 600 terabyte of data. You will create these multiple DBs, and some DB, one DB will store maybe some movie data, let's say Bahubali data, some other data, right? For example, tell me some movies name. I will just remember. Tell me some movies name. RRR, yes, Inception. Okay, yeah, Extraction, yeah, definitely, yeah. I think three will suffice. Yeah, Dark will also, I remember. Okay, so yeah, Flash, yeah, Marvel, yeah, definitely. Okay, let's have these movies, right? So I have 600 terabyte of data, and I can store some movies in one DB, some movies data in another DB, some movies data in another DB, some movies data in another DB. Does this make sense? So sharding based on movie is making sense, right? What is sharding based on movie? Clear? Okay, what is not clear? Sharding based on movie, right? Like you can store some data related to all the users who have interacted with Bahubali, right? Like all the interaction data is with Bahubali. Rajat might be interacting with Bahubali. Ashok might be interacting with Bahubali. All that data will be stored in this DB. Genre is another broad, like you are going more broad in genre. For example, genre might be like, I think genre is like fighting is a genre, romance is a genre, right? Make sense? So one database can have multiple movies. It's not needed that one database will store only one movie data. It is also possible one database will store data for RRR and Bahubali, or maybe for 5 movies. Genre is mostly, I think, like say gaming is a genre, fighting is a genre, romance is a genre. I think that is what genre means, right? No, Codra, I will not be able to repeat the whole sharding part because that will be like way too much. But I think you will be able to understand from now. We will talk about API, just like give me some time. We will define APIs and we will define it. Yeah, so one disadvantage will definitely be somewhat like that Bhaskar has mentioned, that sharding will be unbalanced. For example, Bahubali might be more watched, so there might be famous movies, and there might be unfamous movies. Make sense? The biggest problem is like it will be very, very slow. For example, if I open Netflix, let's say this is Netflix. Here are movies. Then let's say here are my recommendations. Right? Or maybe let's not even talk about recommendation. Let's even talk about even easier part. Let's say I am just talking about my watched movies. Right? This is Rajat profile. And here are all the movies that I have watched. Tell me, getting these watched movie will be slow or will be very slow or will be fast? Getting this list of movies that I have watched. Why it will be fast? Think of it, right? Rajat might have watched Inception as well, which is in this DB. Right? Does this make sense? Or there might be one movie that I have watched here, for example, RRR. Is this making sense? So in order to get the interactions with movies, I have to interact with multiple databases. And if I'm interacting with multiple databases, will that make the API call very, very slow? Will this request become very slow? Because I have to now go through multiple DBs to find the information. Is this making sense? Leave it unbalanced is not that important as well. Unbalanced is just Stuti. Some movies will be famous, right? If some movies are famous, then the data for those movies will be too much. Whereas movies which are not famous will be very less. It's kind of that problem if you have heard of these, like on Instagram, some users will be very like famous influencers problem. If you have heard of it in system design, there's a solution to it, but just like that's not a very big problem. The big problem is the getting previous watched movies will be very slow. It's the main reason. नहीं अनिकेत, फास्ट तो होगा, आप सही हो, लाइक इट विल बी फास्ट, बट आपने कैसे डेटा स्टोर किया है उस यूजर का? अभी आपने शार्डिंग बेस्ड ऑन मूवी करी है. अगर आपने शार्डिंग बेस्ड ऑन मूवी करी है तो आपके पास अलग अलग जगह पे स्टोर है ना, कि अनिकेत ने एक बाहुबली मूवी देखी है वो यहाँ पे स्टोर्ड है, अनिकेत ने इंसेप्शन देखी है वो यहाँ पे स्टोर्ड है. कैशिंग तो हमेशा थोड़ा ना होती है. तुम 50 दिन बाद नेटफ्लिक्स खोलोगे तो कैश में थोड़ा ना होगा वो, राइट? ठीक है, सो इट विल बी वेरी वेरी स्लो. दैट इज द रीजन वी विल नॉट यूज शार्डिंग बेस्ड ऑन मूवी एज वेल इन दिस केस. Is this making sense? A quick yes, and then let's move to the next method, which is the right method. Everyone clear with this? Why it will not work? Yes, Vijay, you are right. Right? So now let's do sharding based on user ID. What is sharding based on user ID? Sharding based on user ID is that I have this 600 terabyte of data. I will shard in multiple databases based on user ID. For example, Rajat might have interacted with multiple movies like Bahubali, like RRR, like Inception, Captain America, right? Like different movies. And now you will, all those data will be stored here. For Rajat and for other users might also be. I am not saying 1 DB will store one user data. 1 DB might be storing thousands of user data, right? But you are dividing based on user. So some user will be stored here, some user will be stored here, some user will be stored here, some here, some here. Does this make sense? And now you are dividing this data based on user data. Is this clear? On user ID, we are sharding based on user ID. For sharding, an algorithm is used which is known as consistent hashing. Not sure if you have heard of it or not. If not heard, then please just go and search about consistent hashing on Google after this, right? But the algorithm that is used to shard the data is known as consistent hashing. It's kind of a like binary search mixed with hashing, right? It's kind of algorithm which uses binary search and hashing to make sharding very, very fast. But you can go and read about it after this class. But it's sharding based on user ID and such that right now you can think of it as a magic algorithm which divides this data magically between multiple databases based on user ID. Yeah. Is this clear? A quick yes. What is sharding based on user ID? Is it making sense? Like making sense? Now this will work, right? Because now if you want to get all the movies that you have watched, you only have to go to one database, right? A quick yes if this is clear. Right? So this is something that we will use, sharding based on. In which, yes, Vijit, you are right. That is what consistent hashing will take care. Consistent hashing will take user ID and will tell you in which database your data is stored. How do you know which database? Consistent hashing is the algorithm that takes care of it. Think of consistent hashing. How does it work? I will not be able to tell you in this class because it's a 45-minute topic. But you can think of it as a magic algorithm, which internally uses binary search and hashing concept, which takes in the user ID and tells you which database / machine this user data is stored. Okay. What is this? Think of it like a magic box, right? Okay, clear? Everyone clear? Do a Google search and you will find it, what it is. Okay, so now this is clear. Great. Now we know this as well, that we will shard based on user ID, which is very, very good. Now let's talk about the last, which was the movie media data. Where will you store the media data? In blob storage. Yes, you are right. Media you don't store in like kind of any SQL you don't store, you stored in blob storage like Amazon S3, right? Or Azure Blob. So these blob storage takes in the media and gives you the media URL. Okay. They are designed, Tanu, in such a way that they are great for storing these kind of media data and gives you the media URL. These are you don't store non-queryable data in all of like SQL or something. Nothing blob. You can do a quick Google search, but this is nothing like blob storage. Is just a storage where you store all this like kind of files you store in blob storage. There is a image you want to store, you will store in a blob. There is a movie you want to store, any media want to store, they will store in a blob storage. Non-queryable format is usually stored in a blob storage, right? Non-queryable format data. Firebase is actually not like if you take Firebase storage, that's actually a CDN, right? So we'll discuss about it in a while. And then Firebase, I think, has a database Firestore, which is a NoSQL database. It's kind of I think a collection document model, right? So Firebase is again like does not take care of any session or anything. So it's really just for starting up. But when you are at scale, something like Netflix, you cannot use Firebase kind of things because it does not let you have sessions. It's a stateless kind of a thing, right? With that, we now know a lot of things. Let me just picture them out, and then we will again start thinking about other aspects. Right now, we know that we have three type of databases. One is storing the user details, which we are sharding based on user ID, right? We also know one more thing, that we will, and this is a SQL kind of a database. This is also SQL kind of database where we are storing the movie details. And since the data is very, very less, you don't actually go about needing any sharding or anything. Since it is just 1.2 GB, you can store it in a single database. And you have another database, which is kind of a blob storage, right? Where you are storing what? Like, what are you storing? You are storing the movies media data. Is this clear? A quick yes. Clear? Okay. Great. Okay. Now, let's say you are the client. What is the client? A client is like, let's say you are watching Netflix from a mobile device, or you are watching Netflix from a laptop. So you are the client, right? From where the request is initiating. Make sense? So let's say you are here. Let me just draw out where you are. Let's say, think of this as a Netflix screen. Please be very careful for 5-10 minutes and you will understand the complete design. And then we will go into 1-2 more aspects, but please be very, very attentive for 5 minutes or 10 minutes, right? Okay, everyone with me, you will be attentive for 5-10 minutes so that I don't have to might be repeat it again and again, right? Please be very attentive. Right, so there are a lot of movies, right? This is movie 1, let's say Bahubali. This is, let's say, Captain America. This is, let's say, Iron Man. Right, different movies. Okay, are here on the Netflix page. Let's say you click on these movies. What will happen? You will go onto a screen like this. Here on this part, there will be movie, which is not played yet. Here, Bahubali will be written. Here might be cast details will be here. Right? Here might be other things will be there, right? For example, maybe the description will be here. And here might be related movies. Is this making sense? Something like this you will see. A quick yes. Right? You'll see something like this. From where you will get this data? You will get this data from movie details. A quick yes. Okay, makes sense. So whenever you press this button, this click, what will happen? Tell me. You will first go to a DNS server. DNS is basically domain network service. Domain network service takes a domain name and gives you the IP address of the machine that is hosting the service, right? So you give the okay, so you give it the domain name, and what do you get? You get the IP address. Is this clear? A quick yes. Right? Of what? Of the load balancer. If you don't know what are these terms, please go and read about all of them. What is DNS? What is load balancer? Load balancer is like a router which takes in these requests and divide them into multiple servers, right? So now there will be app servers here. There will be app servers. These are servers. And this is your storage layer. App servers are good for computation. Storage layers are good for storage. Make sense? No. DNS is not under the control of Netflix, right? So it just gives you the IP address of where is the Netflix hosting, right? Like which server you should hit. This is where Netflix is starting. Make sense? So now you go to the load balancer. Load balancer sends the request to one of the app servers, right? Make sense? App servers, and it sends ki get me movie details. Get movie details. Give me the details of the movie. It goes to one of the DB and returns the movie details, and then you can have a cache here, right? App side cache, which will store the movie details, so that when the next user is coming, this is user 1. When user 2 is coming, it does not have to go to the database. It just directly gets those details from the cache and return it to the client. Is this also clear? And then you return it to the. A quick yes if this is clear. Yeah, I will repeat once. Okay, so think of it. A request starting. So local, not local cache, app level cache, like app layer level cache. So let's say, let me take an example. Let's say Rajat is watching, let's say Bahubali get released now on Netflix, right? So everyone wants to watch Bahubali. So Rajat watched Bahubali. What will happen? It will go to the app server and it will go to the database, fetch the details of Bahubali and return it to the Rajat. But then next time Utkarsh is also watching Bahubali, then Utkarsh don't need to go to the app server. It can directly get it from the cache. Right? Is this clear? So what is happening? First, the request is going to the DNS. From DNS, it is getting the IP address of the load balancer, going to the load balancer. From load balancer, going to the app server going to the database, getting the information, saving it in a cache, then returning it to the load balancer, and then load balancer returning it to the client. For the next user, if the item data is already present in the cache, then it will be directly returned from the cache itself. A cache user, basically there are different techniques you can use cache. I think in which you will use a LRU cache, least recently used. If you have heard of LRU cache, you can use a LRU cache here. Does this make sense? Now this is loaded. Now this is done. Okay. It is fine, Saksham. If it is not making sense, I can repeat it in the end. You can right now think of that we are directly returning it to the client. Cache just makes it much faster, but you don't need to have cache on day one actually. Right? Now this is done. Okay. Now let's say now I press here, user click here. Now what will happen? Tell me. If I have watched Bahubali earlier, will it start from the same point where I left? Or will it start from the zero again? Where I left, it will start from where I have left, right? Last watched. So from where it is getting that information that Rajat had watched Bahubali earlier, and it has watched till 30 minutes. Tell me, it would have gotten that information from the user detail database, right? Make sense? Right? So now the second request, when you are pressing this click button, will go to the first will go to the DNS, will get to the IP address. The IP address will send the request to the load balancer. Load balancer will send the request to one of the app servers. The app servers will then go to the database. And here consistent hashing will be used for deciding which database to go. And then it will return to the user interaction with that movie, that what is the Rajat interaction with Bahubali earlier, and will is sent to the client. Does this make sense? Right? Again, you can also have a cache here as well. Make sense? You can also have a cache here so that all of this going to the database is saved, and you sync the app server and the database after regular interval of time. Right? Make sense? So that your availability is higher and consistency is fine. Even some sync failed, that is fine, because you don't want exact consistency, you can have eventual consistency. Right? Does this make sense? Now, once you have everything, you will form the connection with this database to watch movie. Where is the movie stored? Where is the Bahubali movie stored? Here. Right? So now you have to form the connection here. To store the movie. And then the movie will play. Is this making sense? No, Vijay. No. So here you are not storing any kind of Bahubali details, like you are just storing the interaction of Rajat with Bahubali. You're not storing the video there. Video is stored in blob storage. And the movie URL is stored here. Right? Which you get from the blob storage. You're not duplicating data or long. Okay. So now, if you remember, we are connecting directly from the client to the blob storage for streaming of video. Is this making sense? Is this everyone clear? A quick yes if this is clear, that finally for streaming of videos we have to go to the blob storage. Right? Now, this is clear that for streaming, right now, what we are doing is client is forming connection with the blob storage. So do you see any challenges here? Okay, so when you are directly streaming from the blob storage, you will basically face two challenges. One of the challenges is latency, and the second challenge is bandwidth. Let me tell you why both of these. Why latency is, tell me in India how many databases are, how many data centers do AWS has? I think two. I think earlier it used to be only in Mumbai. I think now there is one in Bangalore as well. Right? I think earlier it was just Mumbai, but I think right now it is in Bangalore as well. Yeah, I think there are two. I have used Mumbai, but I'm not sure. One more is there. Azure has recently launched, like in Hyderabad, just recently added one data center in Hyderabad. Earlier, it does not used to have any data center in India. So think of it, a person sitting in Delhi, right? Think of person sitting in Delhi. Say this is our map. So let's say if I am in Delhi, I have to form connection. My client has to form connection directly with something in Mumbai. This is a lot of distance, which will result in high latency. Because now the network package has to travel a lot of distance, which is going to take more time, right? So one thing is, because of distance between client and data center is large, the latency is more. Is this clear? First point is clear. A quick yes if this is clear. Right? Clear? The second part of this puzzle, like the problem is bandwidth. What do I mean by bandwidth? Like we were saying that there are, let's say, we were saying that total number of users there are 500 million users. Tell me at peak time, how many users will be watching simultaneously? Watching Netflix simultaneously. Like at peak time, how many percentage of users will be watching Netflix as of now? 5 to 10% users, right? Let's say 5%. Let's say 5% people are watching Netflix at peak time. Let's say a new movie series has come out, very, very famous. 5% users are watching it. So how many users are watching right now, like at one particular time? What will be 5% of this? It will be 5 million, right? No, not 5 million. I think 25 million. Right? Make sense? So 25 million people are watching Netflix at one point of time. Let's say all of them are watching in HD. High dimension only. Since we are taking the worst case again. The HD streams at 20 GB per hour. Right? So what is the network bandwidth that is required? If this is the Netflix server, then different devices, all these users, right? All these 25 million users are connected to the Netflix server and asking for packets of information. Right? Is this making sense? So what is the network requirement? Network requirement is there are 25 billion users and they are watching at 20 GB per hour, which will come out to be, sorry, not billion, basically million, which will come out to be 25 into 10 raised to power 6, which is million. And then they are serving at 20 GB per hour, which will become 25 into 20 into GB terabyte petabyte, right? This will become petabyte into R is by R. Okay, this is R. Okay, this is R. Okay, sorry. So this is R. Let's convert R to second. So 1 hour is 60 minutes into 60 seconds. Is this clear? Is this making sense? Right? So now this will cut with this. This will cut with 3. Okay, this will become 25 petabyte into 180. So I can say it as, I can write it as 175 right? So by 175, what it will become? 25, 50. One by 7, right? Makes sense. So I can write it like 10 by 100 by 7 into 10 terabyte per second. So this will become 7. What will be 100 by 7? Can someone tell me quickly? 30. 130 terabyte per second. This is the bandwidth requirement, 130 terabyte per second, which is very, very huge, right? Like what is the internet speed at your location, right? Like what is your internet bandwidth? My internet bandwidth, considering like I use very, very high internet bandwidth at home, is still around 300, 400 Mbps. And what is required from Netflix is 130 terabyte per second, which is very, very hard to achieve. Does this make sense? If you're not able to understand calculation, just leave it, Stuti. Just like do these calculation at home. Those are very simple. I'm not saying one server. I'm saying on system. I have written here system, Netflix system. So on Netflix system, it has to deliver the bandwidth of 130 terabyte per second, which is very hard to achieve. So these are the two challenges: very high bandwidth requirement of 130 petabyte per second. Because of these two reasons, directly serving videos from the origin itself, from the data center itself, at scale is very, very hard, is not going to scale very good. Is this clear? Why this system does not work out? A quick yes if this is clear. Here, everyone is clear. What should I repeat? What is not clear? Don't tell me to repeat everything. Right? What is the doubt, and I can help you understand that. Right? So what we essentially discussed is that since the distance between the client and the blob storage is very, very high, latency will be high, which is not going to. First reason why directly streaming video from the blob storage is not going to work is the first reason. Second is, since if all the clients, there are not just one client, there are 25 million clients at one point of time watching video. So getting very high, like providing that very, very high bandwidth from the Netflix system is very, very hard to achieve. And because of these two reasons, directly streaming from the data center or blob storage does not work. What is the solution? Solution is CDNs, which are known as content delivery networks. If you don't know about CDN, please read them after this class. I will discuss it very quickly. What is CDN is, CDNs are basically these small servers which are distributed all around the world. Right? So let's say within India itself. So within India itself, there is only one data center, but CDNs will be too many. there will be multiple CDN. And these CDNs are small servers. These are very, very small servers, which are distributed all across the world, right? There are multiple CDN providers. For example, AWS is a cloud provider, right? Google Cloud is a cloud provider. Azure is a cloud provider. Similarly, there are multiple CDN providers like Akamai, like Cloudflare. These are CDN providers. They provide this network of small servers which are distributed all across the world. Now, what can you do is you can cache these videos on CDNs. So what will be the advantage of caching videos on CDNs? These small servers are essentially known as edge servers or point of presence, POP, point of presence, right? So caching these videos on CDN, what is the advantage of this? One was latency. Why? Because again, as I talked about that, since CDN will be present in Delhi itself, previously you have to go from Delhi to Mumbai to stream to video. Now you can directly stream video from Delhi to Delhi itself, right? So one aspect is low latency because now the distance is reduced. The second part is bandwidth. Why? Because earlier one data center was handling 130 terabyte per second. But if I let me just do a quick Google search of how many edge servers does Akamai have. How many edge servers does Akamai have? So now Akamai has edge servers, has this much servers distributed all across the world. Right? Make sense? So now let's say if we are using, let's say 100,000 servers. Make sense? If we are using 100,000 servers for this, then you have 1 point. How much storage was required? 130. Earlier, which you used to require 130 terabyte per second from one system, now you have 10,000 servers which are ready to serve this much bandwidth. So what will be the bandwidth per edge server? It will be 130 terabyte per second divided by 10,000, which will become 13 gigabyte per second. Right? So you can keep on increasing the edge servers based on the traffic you are getting. And then each edge server will be able to handle that. Does this make sense? For each edge server, the bandwidth requirement will be less. Is this making sense? So here in your system, when we draw the system, there will also be one more component, which is the CDN. Which is very, very important. And CDN will get the data from the blob storage. And finally, the client will stream the video from the CDN and not basically from the blob storage. I hope you found the class to be useful. If you did, don't forget to like the video and subscribe to our YouTube channel. This helps us create more such valuable content for you. And in case you have any doubt, please let us know in the comment section and we will answer your queries. Also, don't forget to check out the Bosscoders program, which will help you become a top 1% software engineer.